Okay. In this video, I want to talk a little bit about composition of functions. So composition of functions, it's a fancy term for just combining functions, right? So we have these kind of ideas of, in the same way that we combine numbers, addition, subtraction, multiplication, division, we combine functions, right? So I can add two functions and I just add them what's called pointwise. So I take, at a value x, I evaluate f of x and I add it to g of x, and that is f plus g of x. The same thing with multiplication. F times g of x is the same as f evaluated at x times g evaluated at x. Same thing with the quotient. F over g is f of x over g of x. And then the only new idea here is composition. So composition, f compose g of x, we call this little O symbol the composition symbol. It represents the composition of functions. And what I mean by that is it's f of g of x. So we take g of x and evaluate it. We take g evaluated at x, and then whatever we get here, we evaluate f at. So let's look at some more concrete examples of what I'm saying here. And then the rest of this is just a little bit of bookkeeping about domain, which it'll be pretty natural when it comes up, okay? Now, given the functions f of x and g of x, we want to find f plus g, f times g, f over g, and f compose g. Okay, so f plus g is pretty easy. F plus g of x, we just saw as above, is f of x plus g of x. F of x plus g of x. We're given f of x here, so f of x is x squared minus 4. And then we're also given g of x, so plus x minus 2. Combining like terms, this is going to be x squared plus x minus 6. That's f plus g of x, okay? F times g of x, again, is just f of x times g of x, right? F of x times g of x. That is given, in this case, we have x squared minus 4 times x minus 2. F of x times g of x. We're going to go ahead and FOIL this out. So first, x cubed, outer, negative 2x squared, inner, negative 4x, last, positive 8. So that's f times g of x. Great. F over g of x is just f of x over g of x. So that's going to be x squared minus 4 over x minus 2. And I would be okay with that, but we can do a little bit more work because we know that x squared minus 4 is a difference of squares. So this is x minus 2 times x plus 2 over x minus 2. We shouldn't quite cancel that, right? And I make a point of that because it wouldn't be exactly the same. And we'll talk a little bit more about it when we get to our discussion of rational functions. But if we cancel out that shared factor of x minus 2, we're ignoring a hole in the function f over g. So we leave it like that. We just leave it as x squared minus 4 over x minus 2, okay? That has more information than just x plus 2, right? Necessary information, okay? Finally, f compose g of x is just f of g of x. How does that look? Well, that's f of, so g of x is x minus 2. So f of g of x is f of x minus 2. So everywhere where there's an x and f, we put x minus 2. So that's going to be x minus 2 squared minus 4. Okay, and if we want to be nice about things, we can go ahead and FOIL this out and get x squared minus 4x plus 4 minus 4, which is going to give me x squared minus 4x. Okay, that's my final answer. Okay, so now let's do it with these other two functions. So first we want f plus g of x. Again, that's just f of x plus g of x. F of x is the square root of x plus 7. G of x is x plus 1 over x. Very easy. F times g of x is just f of x times g of x. That's the square root of x plus 7 times x plus 1 over x. Okay, I could distribute this if I really wanted to, but I think it's fine like this. F divide g is the same as f of x over g of x. So that's the square root of x plus 7 over x plus 1 over x. Okay. And then I guess if I really want to be nice about things, I shouldn't have a fraction in the denominator, so I can go ahead and give these a common denominator by multiplying this by x over x. This then gives me the square root of x plus 7 over x squared plus 1 over x. Keep, change, flip. X times the square root of x plus 7 over x squared plus 1. Okay, that's f over g of x. Okay, and then f compose g of x. That's just f of g of x. So that's f of, we'll plug in g of x, x plus 1 over x. So anytime we see an x and f of x, we replace it with x plus 1 over x. So that is the square root of x plus 1 over x plus 7. Okay, all done. Great. So this is kind of the idea is we're just plugging things in, right? We're just taking, rather than plugging in numbers, we're plugging in more complicated expressions like variables and functions. So function composition gives us a nice way to combine functions to get other functions, okay? Next, we want, given f of x equals x squared minus 1 and g of x equals x cubed plus 3, we want to find f compose g, and we want to find g compose f, and we want to give the domains of the quotients, f over g and g over f. Okay, so let's take a look at this. F compose g, that is f of g of x is x cubed plus 3. So f of x is x squared minus 1, so everywhere there's an x, I'm going to put an x cubed plus 3. So this is going to give me x cubed plus 3 squared minus 1. Okay, and again, I should probably FOIL this out, so this is going to be x to the 6th plus 6x cubed plus 9 minus 1. This is going to give me x to the 6th plus 6x cubed plus 8. And if you're lost on that foiling, I encourage you to go watch, I have a video on foiling. I can't go over that. We're kind of far into the topics here, but if you would like to review foiling, I have a video on it. It's in the college algebra playlist. So next we want to find g compose f. G compose f of x, that equals g of f of x is x squared minus 1. And then g of x is x cubed plus 3, so I have x squared minus 1 cubed plus 3, so everywhere where there's an x in g of x, I just plugged in x squared minus 1. And I can FOIL this out. I can rewrite this as x squared minus 1. Let's do squared times x squared minus 1 plus 3. This is going to give me x to the 4th minus 2x squared plus 1 times x squared minus 1 plus 3, which is going to give me x to the 6th minus x to the 4th minus 2x to the 4th plus 2x squared plus x squared minus 1 plus 3. That is going to give me, combining like terms, x to the 6th minus 3x to the 4th plus 3x squared, and then minus 3 plus 1, so plus 2. Okay? Alright. Next, we want to find the domains of f over g and g over f. So let's start by just writing it out, right? F over g of x, that's just f of x over g of x, so that's x squared minus 1 over x cubed plus 3. Now remember, when we see a quotient, when we see something being divided, my immediate reaction should be if I have, like, for example, 1 over u, I need u not equal to 0. I can't divide when it's 0, right? So if there's something that makes this 0, I need that to not be in my domain, because otherwise I'd be dividing by 0. So I'm just going to take the denominator and I'm going to set it not equal to 0. So x cubed plus 3 cannot be 0. Otherwise, we have an issue. Okay? So x cubed cannot equal negative 3. And x, taking the cube root of both sides cannot be equal to the cube root of negative 3. And that's the same as x cannot be equal to negative the cube root of 3. Okay? So that's not in our domain. The only thing left to check is for any holes. I don't see any. I don't think there are any. So we have that my domain is, we can write it as the set of all x such that x is not equal to negative the cube root of 3. Or we can write it in interval notation as everything from negative infinity to negative cube root 3 union negative cube root 3 onward, not including negative cube root 3. Okay? And then finally, g over f. So g over f of x, that's just g of x over f of x. So x cubed plus 3 over x squared minus 1. Again, my immediate reaction when I see a quotient like that is to set the denominator not equal to 0. I can't have it be 0. Otherwise, I'm dividing by 0. That's a no-no. So x squared minus 1 cannot equal 0. So x squared cannot equal 1. And taking the square root of both sides, noting that I have to do plus or minus, x cannot equal plus or minus 1, which is plus or minus 1, right? Square root of 1 is 1. So x can't be plus or minus 1, right? So my domain is going to be, I can think of it as the set of all x such that x is not equal to plus or minus 1. Or I can think of it as everything from negative infinity up to negative 1, not including negative 1, along with everything strictly between negative 1 and 1, along with everything that comes after 1. Okay? Those are the two ways I can think about the domain. And anyone who is like the set of all x such that if this notation here bothers you, we're specifying x is a real number implicitly for the purposes of this this video. Okay. So, but that kind of wraps up what I wanted to say about composition of functions. If you found this video helpful, please consider liking and subscribing. Thanks.